In this episode of the Tech Stack, government kickbacks and semiconductors and hot takes from hot chips. Next. Welcome back, ladies and gentlemen, brothers and sisters. Dave Altavilla for Hot Tech here on the Tech Stack. Today is Friday, August 29th, don't you know? And I am joined, as always, by my esteemed colleagues. We've got Mark Wiener from Smart Tech Research and the Tirius twins, Jim McGregor and Francis Sadeko. Good to see you, gentlemen. Happy Friday to you. Wonderful, wonderful day.
Likewise. Yeah, we decided to do our hair. We decided to do our hair differently so you can tell us apart.
And Jim, I hear you may have made another revolution around the sun or something like that recently. Is that what happened?
Revolution around the sun?
Yeah, otherwise known as a birthday, Jim.
A birthday, dude. Oh, that was.
Had to bring that up, didn't you?
Was that a senior?
You're starting to slow down already.
It is slowing down. I
was going to say that was a senior moment.
I'm thinking of like the next 12 weeks of travel, and I'm like, yeah, I'm actually circling the Earth like twice, but.
That's all right. Well, hey, Jim, happy belated birthday. I don't think it was today, but it was, what, a couple days ago, maybe?
It was yesterday.
It was yesterday. Okay. Well, you know, you are the elder statesman on the team, so we'll look to you for wisdom today.
You're pulling out all of the puns today, aren't you?
Would you expect anything less, my friend?
No, I would not expect anything less.
Of course not. But we have a few interesting tidbits on tap. The Hot Chips show, the Hot Chips Emporium, if you will, happened this week. And Jim, you were boots on the ground. Francis, were you boots on the ground, or were you admiring from afar?
No, I wasn't. Yeah, Jim's our man on the ground.
Okay, so we're going to be picking your brain there, James, and we're going to be getting into all the different technologies. This is a type of show that's sort of unique in a way that a lot of companies don't really announce what they're going to talk about. It's sort of, last minute kind of stuff or inside almost baseball that, comes up and gets surfaced at this show. It's not based on the usual cadence of press releases and announcements, right? It's kind of, peel back the curtain, open kimono, and, we get some pretty interesting tidbits recently. And this year, there were some significant themes that were emerging. Networking stole the show. Lots of different new technologies and connectivity, new architectures, processors, graphics and accelerators. A few different players firing, Jim, right? And I guess maybe we'll start with you, Jim, since you can probably tee us up, and then we'll get some impressions from the others. What were the high points in networking? Let's talk about that, because as we know, if you can't feed the beast, AI or otherwise, with copious bandwidth, it starves, right? So what do you got for us in that space?
Well, obviously, this has been a launch show for processors and GPUs in the past, but, it's still really focused on the hot topic, which is AI. But, it's shifted more, especially this year, towards, what are those other technologies we need for AI? Not just the GPUs and accelerators, but what else do we need? And networking is definitely top of the list there. So, talking about not just about scale up. Scale up is a huge issue in the industry right now, because the rack has basically become a single server. So how do you make all those accelerators within a rack look like a single GPU? So a lot of different scale up networking solutions, from NVLink to UA Link to scale up Ethernet, with Broadcom's Tomahawk solution, to scale out, where obviously you're looking at Ultra Ethernet or competing solutions, InfiniBand, even NVIDIA's latest solution talking about scale out or scale across with their Spectrum XGS solution, which is kind of a version of Ethernet, if you will, an optimized version, if you will. And then obviously optical is also a key feature that everyone's talking about right now. opticals almost become required, for that scale out solution or scale across solution. But, now people are really talking about it even for that scale up, actually having optical within a rack. So those were kind of all the key terms and all the key topics for networking at hotchips. And I got to say, the hotchips is such a geek show. It gets so deep in the technology that your head just wants to explode after you leave.
It is often we get the mind bending data dump from these semiconductor players and technology players, and so I feel your pain, brother. Absorbing it all sometimes can be a little bit of work, but that's all right. That's why they put you where you are. But let's talk a little bit about Spectrum XGS. This is where folks are going optical across data centers. NVIDIA's staying with copper. What's Spectrum XGS about?
Well, first off, they're staying with copper only really in the scale up, and that's within the rack.
Right.
They want to stay with copper as long as they could. Although other players that were there, Celestial AI, Air Labs, and Light Matter, we're all talking about really using optical throughout, not just the data center, but also within the rack. NVIDIA wants to stay with copper as long as they possibly can, and rightfully so. It's less expensive, but the faster you try to push things across copper, the shorter the copper links get. And you're even having to move at this point in time from having top of the rack switches to the middle of the rack switches to make sure that you can actually, be able to maintain those links in a deterministic manner. So it's becoming a bigger and bigger challenge. There's no doubt that eventually we're going to get to the point where you have to have optical even within the rack, but NVIDIA is pushing copper as long as they possibly can. Well, I think the rest of the industry is trying to move on as quick as they can. But everything beyond that, even especially with Spectrum XGS and Spectrum X, definitely optical. How do we get to optical, and how do we get there efficiently and as quickly as possible?
Yeah, interesting. Go ahead.
Sorry, Dave. I think that does make sense, though. Just because, look, I think it's inevitable we're going to go optical, right? You use the term, Dave, feeding the beast, and at some point the beast becomes so ravenous that we won't have a choice other than to use optical, even within the rack. But I think it makes sense. Hey, if you can use and continue to use without degradation of performance, copper, it's cheaper both in terms of actual materials, but also in terms of power. Why the heck not, right? And I think it's just use the best tool for the job depending on what you're trying to do, and how far out of a horizon you're trying to plan for as you design these data centers. So I think it makes sense.
Yeah, I'd have to agree. If you look at it, it's about where's the friction too, right? So if copper can get the job done, you stay there. If you need the bandwidth and copper can't make it happen, like you say, right tool for the job. But if you look at the internet backbone, right, it's built on optical. I mean, there's optical network switches everywhere in high-speed communications. And so it's a natural migration that essentially the backbone moves to the data center because we got to feed it. We got to open those pipes. And so scale across definitely makes sense for optical, but it's fascinating technology too, like all the different wave division multiplexing. And I mean, it's super deep, heavy duty stuff. Mark, what do you think about this brain twisting solution or these high speed interconnects?
Well, well, the first thing I can attest to is that this particular show is not like Comic-Con. it's
although the same people might be going there.
Yeah, unless there were people dressed up in costumes. I think the observation you made, Dave, was the right point. Is that the interesting to me is that optical obviously is very expensive, but it's been there for a period of time, certainly at the backbound data center data center level. But here's the nature of technology. I mean, it will come down in cost, and then the more it gets deployed, the more the cost factor becomes a less key figure. When technology is more expensive, but it delivers a particular value proposition, it's always going to be higher priced. The question I have, though, for Jim, what's really interesting to me about what's happened over the last few years, and I'm sure that there was a lot of evidence here, is you're seeing companies that are not in the silicon business, but in the software business. They're more and more going after their own custom silicon designs. And you've got companies like Meta, you've got other companies that are saying, it's feasible for us actually to employ our particular architecture that optimizes whatever solutions we have. And, in a fabless model, which has been, now validated, Apple's probably the poster child for that. You've got Qualcomm, you've got AMD. So the question I have for Jim is, did you see any evidence that is now starting to get real traction? I mean, there's even companies like Dell have talked about, hey, maybe we need to be in the have our own particular silicon offering. And that was, you would laugh at that 10 years ago. But any thoughts on that?
Well, I think the industry has made it much easier to do custom silicon now than ever before, with the EDA tools, with the IP availability, and the movement to chiplets, especially being able to put things into a single package a lot quicker. So, I mean, it's given a lot of people reason to start thinking about that from a differentiation standpoint, especially when you can go to market pretty quickly with a custom solution. However, it's still a huge trade-off. You have to remember that doing a custom solution is still going to take you time. And you have to have a dedicated engineering team if you want to keep spinning that on an annual cadence at the same rate that these dedicated silicon providers are. And that's always kind of that trade-off of, okay, we can do it now, but can we keep pace with the rest of the industry? And obviously, we've seen that in mobile, with a lot of the mobile guys going to doing their own custom ARM-based or ARM-compatible solutions. We've seen that with the hyperscalers now doing their own custom accelerators and their own custom processors in some cases. I think that's becoming more and more of an option. And I think that not only is it going to be an option for companies to do it themselves, but to look to partners. So a lot of these guys are looking towards partners like Marvell and Broadcom and MediaTek to do their custom chip designs or separate design houses. But also, I think Intel and AMD are making it easier to do custom chip designs. So do I think we're going that direction? Absolutely. Do I think it's necessarily going to have to be where you have to employ your own semiconductor design staff? No, absolutely not. I think, matter of fact, if anything else, we're going to see more and more of those solutions come from the traditional semiconductor providers doing custom silicon solutions. And just for a note, Intel has actually done custom silicon solutions for one customer in particular, HP, or now HPE, for decades. In fact, a lot of times those custom features were incorporated into their standard chips, but just defeatured or unwire bonded, so that it was used. The same die was used for everyone, for the general market. So, I mean, that's always kind of been there, but you had to have a really, really big, checkbook to be able to actually get Intel or AMD to do a custom chip. And I think that's changing. And you got to remember that, we have multiple processor architectures now with x86, with ARM, and RISC-V even coming up. Matter of fact, we've seen some RISC-V solutions, not just for microcontrollers, but all the way to HPC. So, I mean, that's making it more competitive. And I think that we're going to see that even from the accelerator perspective, whether it's an FPGA, a GPU, an AI dedicated accelerator. So I think it's going to become much more competitive and more likely that we're going to see custom solutions.
Yeah, I think the key to custom solutions, though, is scale. The company, like you mentioned, Mark, the Facebooks or the Googles and so forth, they have to have the scale of the workload to take advantage of that custom solution, because frankly, they're never going to be able to keep up with the NVIDIAs and the people that are doing the general purpose GPUs for various different kinds of workloads, right? But if you have enough scale on a particular workload or a particular set of workloads, it might be worth it to then do a custom solution that optimizes for that workload. But because of everything that's involved in it, it has to be worthwhile, and the thing that's going to make it worthwhile is that scale. So I think,
and by the way, that's where a MediaTek would come in, because MediaTek can accommodate those kind of designs. They may not be purely custom, but they can be custom in such a manner that it makes economic sense. And the point that Jim made, I agree with, is that the humorous thing about this is that ever since Apple got into the silicon business and did their custom chips, and what is now, we're now year 3, year 4, the thing that most people don't get is that Apple spends a lot of internal resources and money. It's not for the faint of heart. You know, if you're a PC OEM, for example, I'm not sure a Dell or an Asus or pick out the company that would be willing to spend those kind of dollars in businesses that are low margin businesses. I don't think the advantage they would get is going to be that so significant they could rationalize that. But that's where the Qualcomms of the world, come into play. So I just want to make that point, because sometimes, yeah.
And just to let you know, actually, Apple's been doing this for a decade now, actually, on its mobile site. So, and they actually acquired a semiconductor company just to do this. So, I mean, most companies aren't going to go to that extreme to actually get into it. Basically comes to, I think, anywhere, if you're willing to spend 50 to 100 million to have somebody tweak a chip for you, that's one thing. Or are you willing to spend several hundred million to have somebody do a completely custom chip for you? And, that's a big commitment.
Yeah, it's an interesting dynamic for sure, and I think the higher level of extraction that the EDA tools guys are getting to now, with AI doing place and route and all these different super powerful tools, it does make bespoke silicon a much more feasible proposition. So it's fascinating stuff. Let's touch base real quickly one more time on interconnect before we go to processors, because there were some exciting processor announcements at the show as well. Co-package optics, Jim, are we ever going to get to a point where we're bringing light right to the chip?
Oh, absolutely. And it's funny because it's always been 2 years out in the future. I made a prediction that we'd have them by the end of 2025, and that was even before I knew what was coming at GTC. And we're there. We're definitely there. There is NVIDIA did a great job of building an ecosystem, saying, listen, we can't wait 2, 4, 6, 8 years for this. We have to have it now. So they, especially with the Rubin generation starting in 2026, we're going to see those co-packaged optics solutions. And, will we have missteps? Absolutely. But I think ultimately, and not just because of speed and performance, but because of the reliability of these solutions, I think that, we're going to see a very quick transition to using co-packaged optics as much as possible. It's still going to be expensive in the early days, but like we've talked about, it's going to be a necessity going forward.
And this speaks to the best tool for the job, right? We just got done talking about how NVIDIA wants to keep copper as long as we can, but that's for a specific use case. It was for in the rack scale up, right? In the same manner, or on the other hand, they are leading the way with co-packaged optics for that type of use case, which is really scale out and scale across. So so I think it speaks to that. Hey, there's many different problems that are needing to be solved, and we got to find the right solution for each thing.
Yeah, makes sense. I always think about the co-package optics challenges, and I think about the actual physical interconnects, the actual physical connections. Are they getting to a point, guys, where it's manageable from a manufacturing standpoint and from a design? And it just seems like the connectors specifically are maybe bulky, or I don't know, unwieldy in some way.
Actually, it's funny you bring that up, because that was one of the key things at hotchips was different ways of doing those co-packaged optics, from doing, maybe just the optics in a silicon substrate layer, to actually, having them as a separate die. There's multiple ways to really implement these co-packaged optics solutions. So I think we're going to see a lot of innovation there. But with the advancements that we have in manufacturing technology, and packaging technology, that's really important here. Packaging is probably even more important than the manufacturing side. We've got to a point where I think it's very, very feasible.
Well, I think one thing to keep in mind is anytime you're doing integration, which co-package is a type of integration, right? Anytime you're looking at that, you're looking at things like adoption rates and innovation rates of the different things that you are integrating, but also failure rates of the different things that you're integrating. So you have to really understand which parts fail, which parts don't more often or not, and modularize those areas so that the LRUs, the line replaceable units, are down to the part where you can just very easily, if something fails, pull it out and pull it back in. And I think when you look at some of the solutions that came out of GTC from NVIDIA, but some of the other solutions that Jim has been referring to, those are the kinds of things that I'm looking is how are they solving some of these integration factors for that particular situation.
Yeah, it's fascinating stuff. Meanwhile, copper's still exploding. I think it was NVIDIA's earnings call. Spectrum X revenue was like off the hook. Of course, they're selling a lot of Blackwell, so that would do it.
Yeah.
But it's impressive stuff. And man, check out NVIDIA's earnings too, as a sidebar here, if you want to see impressive stuff. Even though they took an $8 billion hit for not being able to ship to China in July, they still made the number.
Wasn't it like 800 million or?
No, it was 8 billion.
No, that was a big number. That's a big number.
Yeah, they quantified it last quarter on the earnings call and when they guided up soft, it was a moderate guide to 45 billion from 44, and they put up 46.
And just to clarify, that Spectrum X is both copper and optical, so you can have either of those solutions for Spectrum X, and definitely Spectrum XGS is optical.
All optical. Got it. All right. Let's move on from interconnect to processors. One of the interesting releases that I saw out at the show, or that I saw come across the wire, I should say, because Jim was out at the show, I wasn't, was Clearwater Forest, which is Intel's new Xeon 7 line that they gave a little tease for. Next generation E-cores, built on Intel 18A, which was kind of the highlight for me. They're actually showing the chip, and it's built on their 18A process. It speaks to Intel Foundry. It speaks to execution in that space. Jim, what do you got? Because I was just like, wow, that's good to hear.
Yeah, I think everybody was very happy to see that 18A moniker on there. But quite honestly, for me, this is, and I'm going to really geek out here, this is probably one of the most exciting announcements for me, is the Clearwater Forest. It's going to be the next generation Xeon 7 with the E-cores. And why is this important? Because we already saw what Intel did on Lunar Lake with their new generation of E-cores. They went from actually handling about 20% of the workloads on a PC to 80% of the workloads. And they're using a lot of that same technology that went into Lunar Lake E-cores now into the server products that are going into Clearwater Forest. So, I mean, I expect huge benefits out of this generation of efficiency processors. And once again, it's really designed to be as efficient and competitive as possible. So it's not really designed to be everything to everyone. So it doesn't have hyper-threading or anything like that in it. It was really just focused on this high core count E-core type of performance. And I'm like I said, I'm excited about this because I think this is probably one of the biggest jumps for Intel in quite a while.
Yeah, this is a classic. If you look at the way it's architected, high core count, high density, core density per socket. This is your basic cloud native, processor. Doesn't have hyperthreading because noisy neighbor has been an issue. I think it's less of an issue now. It's impressive to see them still advancing and building it on their own process. Do you think 18A is going to be the full run production vehicle? Was there any word on that?
As far as I know, it is. And 18A was always, and 18A, we need to clarify this. 18A was always on schedule, and it has been on schedule. It hasn't received as much external customer demand as they'd hoped, but a lot of that had to do with execution of their PDKs and stuff like that, and not being optimized, I think, for some of the other market segments like mobile. But for the server segment, it's been on track, on target for the Intel products from day one. So I expect that. And we're going to see 14A. They've already got products committed to 14A for the next generation. So I don't see that changing for Intel.
Yeah, let's bring Mark in on this, because to me it marks a moment in time where Intel regained some confidence. What do you think about Intel's prospects, Mark, whether it be from a process standpoint or competing a little bit better with AMD in the data center for core
Yeah.
density per socket?
Well, let's face it. Intel needs a win, and it's refreshing to hear that. And I agree with what Jim just said. Is that the Xeon stuff doesn't tend to get a lot of sexy coverage, but this is the timing couldn't be better. So they really do need a win. I think if they do execute this on time, I think this will be the first proof point, the first advertising vehicle where you might be able to collect more customers, which their foundry business desperately needs. We all know that. So I'm glad to hear that, because if I had heard something a bit different, that things look a little bit sour, then it's a different ball game. But I think this is, if you're Intel, you couldn't hope for better news to help build your story that their foundry capability is the real deal.
Yeah, absolutely. Francis, what are your thoughts on this?
No, I'm right there with Mark, definitely, and I think Jim's comments too. I think for some reason there's been a lot of maybe obfuscation or maybe some not so good press regarding 18A, and I honestly, as an industry watcher, I don't understand what that was based on, because everything I've seen around 18A has been on track, and maybe they haven't been able to talk as publicly just because of their different agreements with their customers. But from my understanding, it's getting some traction as well from an external customer standpoint. I think that's Jim, correct me if I'm wrong, but I think they publicly stated that. So I think I think it's on track, and it'll be the backbone, I think, or the foundation with which they execute their recovery.
Yeah. I think you hit the nail on the head with that, Francis. I think there was some misinformation out there, because I remember, I think it was an innovation back. I spent some time with Jim Johnson, and he was showing me, defect density per wafer on 18A and its trajectory versus, their previous gen process and versus TSMC's, 3 nanometer node and all that. And it looked pretty good. So I don't know where the smoke was coming from and the issues that were bantered about 18A, but seems to me like this is a great proof point vehicle. Clearwater Forest, come on out. Did they give you a time frame roughly, Jim?
For Clearwater Forest, no, they didn't talk about introduction timeframes, but obviously this is a 2026 product, along with the rest of their Xeon 7 product line. So we'll learn more about it probably throughout the end of this year.
Cool, good stuff. Other chips, other processors. What did you see at the show that piqued your interest?
A lot of it was talk about stuff that's already been out there. IBM talked about Power 11 and kind of hinted towards Power 12 in their chiplet architecture, which they're very excited about. Evercore, on the lower power side, we had two companies. We had Evercore talking about kind of an ultra low power processor or family of processors that they're developing and have working on, that will actually be able to use energy harvesting, so like RF harvesting and stuff like that, or solar or whatever, to be able to actually power these things almost forever. And these are deeply embedded applications, not something you're going to be using to run an application or anything like that. But that's still interesting to be able to think that you don't need a battery. You can actually run these forever just by doing like RF harvesting.
That's
the other one,
it is cool. I've actually had not heard of that.
It is challenging to do energy harvesting. And to actually, usually you think about it just from a sensor standpoint, be able to power a sensor for pretty much ever. But, to actually have a processing solution that can actually use energy harvesting is pretty significant. Freescale worked on that for years as well. NXP, I believe, has a few solutions around that as well. The other one was Meta. Meta talked about their processing solution for their Orion AR headset. And it's a very much a distributed processing solution where they have 3 distinct chips. And actually the solution will use 4 because you're going to have one for each eye, but it has 3 distinct chips, one for the eye processing and tracking, one for, I think, the external tracking, and then one that goes into a puck that, external processing solution you're going to wear. And we've seen kind of this solution also from Qualcomm with their AR solution, where they're trying to break up chips into different functions. Theirs is more by function, whereas I think the Meta solution was actually more by actually just breaking up the computing capabilities. And it's going to be interesting because I've been saying for a long time that if we're holding a rectangular device next to our ear and, in front of our face in 10 years, I'm going to be very disappointed. And we really need to think about, disaggregating the smartphone and figuring out how and where to place these these technical solutions, whether it's the wireless connectivity, the computing, the graphics, whatever. And I look at this, and Meta hasn't always been the best at maybe marketing or bringing products to market, but they have been a leader in technology, and I'm very happy to see them kind of pushing this kind of distributed architecture. What do you guys think? Do you think this has legs, or do you think I'm just crazy?
Well, I think it's go ahead, Francis.
Well, believe it or not, Jim, 15 years ago, as a younger analyst, I actually wrote a study on distributed architecture for these types of devices. So we could pull that up, and it's actually starting to come into fruition. And it only makes sense, not only for the main devices, but within the devices, like the AR products that you said. You can't do a form, fit, and function appropriate like AR glass without distributing the capabilities. It's just physically not possible. So yeah, I think it's the right way to go. And as technology evolves, that's just going to continue to get more powerful and more capable within the power envelope that is required. So I think that's definitely the way to go.
I think it's fascinating. There's 2 things that sound almost blasphemous here, right? One, Meta.
Just 2, Dave. Just 2.
Meta building their own mobile chips, and
Right.
suggesting that they'd historically partnered with Qualcomm.
Correct.
And 2, you're speaking of the death of the smartphone, kind of, sort of.
I think it's the evolution, Dave. It's the evolution of the smartphone, not
you go. Not the
Right.
death. That's a much better word. The evolution of the smartphone. It's disaggregated. Mark, what do you think about the potential disaggregation evolved smartphone?
Well, I think
smart device.
I think the observations that Francis made is absolutely true. There's the laws of physics, and you need a distributed architecture to do the kind of things they want to do. Now, the point that Jim made is a good one, in that I keep saying Facebook, but Meta, has always struggled a bit with the marketing stuff. I think they've done a pretty good job on the device side. I don't think they've gotten the kind of results they'd like to have from a purely a business standpoint. But as we know, Zuckerberg has been making some huge bets on AI, on the AR VR side in general, to the chagrin of a lot of people for a bunch of different alternative problems from a privacy standpoint and a data access standpoint. But I think, frankly, from just a physical device standpoint, I think, there is going to be some compelling hardware that we're going to see that may not necessarily include Qualcomm, which has been the historical vendor that has partnered with Meta. But it goes back to my, the observation I made earlier, that if you had told me, 10 years ago that a company like Facebook, because they were called Facebook 10 years ago, they might actually be contemplating some custom silicon, I would have said you're crazy,
Well, the only thing I would add to that is let's not write off, their current partners yet, because just ask Apple how difficult it is to do their own
Agreed.
5G chip, right? And I think there are certain capability, and Apple's got the war chest, R&D war chest. If anybody was going to be able to do it, they'd be able to do it, and they've had struggles. And so I think there are certain capabilities that strategically are going to be harder to replace with your own thing as than others. So I think we need to be a little bit less peanut butter spread with a comment such as that. Not to say that they wouldn't, but I think there's going to be certain areas that are more ripe for that kind of customization versus not.
I couldn't agree more. And, Apple is the poster child for it in the 5G modem standpoint, because they really haven't proven their chops yet that they have a high performance 5G modem. I mean, they are deploying it in some of their models, but I think Qualcomm still has a superior solution.
6 generations behind in capability.
Yes, exactly.
No, good points, gentlemen. Absolutely, totally agree. I think the other thing you certainly need to count on folks like Qualcomm, especially Qualcomm, who is just like a patent IP juggernaut, is that they're going to evolve with the times here as well. They're on a big revenue diversification plan and strategy right now to get into the PC space. You'll see them they're already doing plenty in the XR headset and glasses space. Wearables,
yep.
So I mean, totally, you're going to see them evolve with this as well and do some pretty magical things. So it's exciting. It'd be nice, as you say, Jim, to get the screen out of the face all the time and be a little bit more up and immersed in reality, or having augmented reality over it, whatever. But being in the moment rather than in the screen. So. Good stuff. All right, lightning round, gentlemen. Let's talk about government kickbacks and semiconductors. Getting the government in our chips. I don't know if I'm a big fan of that, but I want to pose the question to each of you to close out the segment here, because we got to wrap. Let's start with Francis. You tend to be a kind of a neutral Switzerland guy, I think.
I do.
What do you think about government getting all up in our chips from 15% kickbacks for AMD and NVIDIA to a 10% stake in Intel? What do you think about all that?
Well, if you wanted me to do something not Switzerlandy, you're gonna be disappointed, because I think my answer will probably be in that category. I think there's a balance to be struck, right? Clearly, there are certain companies and certain capabilities that are of strategic interest to the government, and just like any other entity, they're more than welcome to make sure that those interests are protected. But the other side of that coin is also, though, part of what makes American technology capability and frankly global technology capability so strategic and so capable is their ability to innovate and their ability to adapt quickly. So there's a balance to be struck there, with a little bit of investment or help from the government, but not so much oversight and involvement that it stifles innovation. So I think it's never one or the other. It's always, with me, it's always best tool for the job. There's a specific problem that needs to be solved, and everybody has a role in a certain swim lane to help that happen optimally. Whether it's going to happen or not, I mean, obviously there's people involved, so there's going to be other factors that are part of that. But that's kind of my stance on these kinds of things.
Francis, the consummate diplomat. Well said. Well said. Jim, I don't think you're as diplomatic sometimes. What do you think, buddy? What do you think, buddy?
Well, first off, I think encouraging innovation in our industry is critical. And that can be done through a number of avenues, through, tax rebates, through investments. I'm not against the government receiving some stock options, or stock in a company for that investment, stuff like that. However, this kickback, this 15% kickback, is a bad idea. That's interfering with the actual interaction with the market, and I think that's going too far.
Yeah. Good point. Good point for sure. Mark, do you have a polarizing opinion on this, or are you more down the middle like Francis?
Me polarizing? I'm not a polarizing type of guy, but I wrote an article about this last weekend. I'm a free market, laissez-faire type of guy. I like the market to speak and help companies self-correct. The Intel 10% stake, I can live with it because I'm a pragmatist. There's national security issues about it. I'm not crazy about it, not because I got anything against Intel, because I want to see Intel succeed. But the challenge is who's making those decisions. I mean, if you flash back 10 years ago, when AMD was having a lot of issues before Lisa Su arrived, and the Lisa Su example is a very instructive one because it proves that if you get the right senior leader in place, you can turn around a company, which exactly, and she's got to get a lot of credit for that. If you flash back to 2010-ish, when AMD was struggling quite a bit, should the U.S. government take in a 10% stake in AMD just to keep them around? Probably not. So my struggle with, again, of this is that who is a decision maker? Who's making this decision? Clearly, in the Trump era, it's Donald Trump. You have a conversation with him, you end up, saying, "Hey, I'll give you a deal, 10%." So again, I can live with what happened with Intel and the 10% thing.
Yeah.
And it's probably dangerous to compare the Intel of 2025 to an AMD of 2010. I mean, Intel still is a company that has a lot to offer, and they play in a lot of different categories, and we've talked about that. But at the end of the day, I'm just I struggle with who gets the golden ticket to get a they don't need a loan. We'll just put 10% of the company into there, and that's to me preferable than giving them a loan at 0% interest.
Well,
so that's kind of where I
it's
go
preferable also to just a handout, right? We saw in previous government actions that it was just a handout with no accountability at all as to how that money is being used. And I think whether you like the situation or not, there's a little bit more control in this kind of situation in terms of accountability and the need for Intel to continue to perform.
Yeah, totally agreed, guys. I'm a little bit more Switzerland this time myself, when I usually would take a hard line on things like this. But I think, to Jim's point, the 15% kickback for NVIDIA and AMD, to me, sounds hypocritical. Oh, you can't ship to China. Oh, but if you give us a little piece of the action, you can ship to China. Like, what? Like, so I have an issue with that, and also its effect on profit margins and things like that for these companies. And so I'm not a fan of that. I am, a little bit more pro 10% stake in Intel. I think what's different, to Mark's point, what's different about Intel versus when AMD was taking a knee years ago before Lisa Su stepped in and righted that ship marvelously, by the way, was that they're a fabulous semiconductor company. Yes, they were designing products here in the US, but they were still manufacturing overseas. Intel is one of the few remaining manufacturing juggernaut powerhouses here in the US, and we need to sustain that manufacturing infrastructure, in my opinion, for the semiconductor industry. So I think it's a good stake to have. And if we look at our competition competitively, China has many state-funded companies, obviously technology-based companies. And so I think it's okay for us to step on equal footing with them in certain spots, where it makes sense. Intel, I think, kind of makes sense. I don't know. Maybe I'm being too Switzerland again. Sorry, Francis.
More the merrier.
And with that, gentlemen, I think we should wrap it up because we've hit our time limit here. But it was wonderful to see you, as always. Great sharing insights with you. Thank you for your takes from Hot Chips 2025. That was fascinating stuff. Chips that can generate their own power. I love the sound of that. Great catching up with you all. And folks, remember to catch us on the web. You can find us at thetechnologists.net, TechStack and the Technologists on YouTube. We're everywhere. We're all over the socials. We got iTunes, and Spotify. Lots of different channels we can catch us on. Hit thumbs up and subscribe. And so you get notified when we go live on the next one. And until the next one, thanks for joining us on the Tech Stack.